All right, IM3 classes. Today we are covering the last day of transforming parent functions. Today we're going to be covering two more parent functions, the square root and the cubic function. Let's go ahead and start with the square root, filling out, seeing what the actual parent function looks like. So starting off, the transform f of x equals square root of x. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, right? Notice this table doesn't start with negatives like the others did in this unit. The reason why it doesn't have negatives is because there's you can't take the square root of a negative number and get a real number to answer. So like square root of -4, there's not a real number you can multiply times itself to get -4. All right, some people might think square root of -4 is -2, but then if you square -2, do the inverse, -2 times -2 is +4. So no negatives on this one. Let's go ahead and plot this real quick. 0, 0 is right here. 1, 1 is right 1, up 1. 4, 2 is right 1, 2, 3, 4, up 2. And then 3 9s or 9, 3, right 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. Looks like this, and it's kind of like half of a parabola on its side, like that. The transformation function, what it's going to look like when we're transforming it. If you have an A out in front of it, that's going to stretch it, shrink it, or flip it. Square root. If you have an X minus some H value underneath the square root with the X, that's the horizontal shift left to right, and then a plus K outside the square root. That's the vertical shift up and down. The important point, like all the others, is 0, 0. Generic shape. I don't know. Half of a parabola on its side. That's kind of long. I don't know, half a curve, or just, I don't know, just sketch out the shape. Describe it however you want. Follow your heart. The domain, so those are the X values. If we already talked about it, you can't have any, you can't take the square root of a negative, so the domain has to be positive values. So it's going to be 0 to positive infinity. So X is between 0 and positive infinity. Y values is the same thing. You're not going to get a negative value when you're taking the square root of something. So Y, this should not have. Y is between 0 and positive infinity. There we go. Let's take a look at the cubic function. So the cubic function, you just cubing it. So remember, the cubic function x cubed means you're doing x times x times x. So -2 cubed, that'd be -2 times -2 times -2 is +8. -1 cubed is positive. Oh, nope, never mind. What am I thinking? -2 times -2 is +4 times -2 again is -8. There we go. -1 cubed is -1. 0, 1 cubed is 1, 2 cubed is 2. All right, we'll plot these points. -2, -8. So that's to the left 2, down 1, 2, 3, 4, 5, 6, 7, 8, all the way at the bottom. Okay. -1, 1 is left 1, down 1. 0, 0. 1, 1 is right 1, up 1. 2, that should be an 8. That's right 2, up 8. And so what this looks like is, that's not, should be crossing. It's going to be this nice smooth curve. That's actually not too bad. I didn't do too bad of a job with that on this one. The transformation function, just like the other ones, the A on the outside stretches it, shrinks it, or flips it. A -h inside parentheses, that's getting cubed. That's going to be the horizontal shift left to right. And then plus a K on the outside is a vertical shift up and down. Important point, HK, still like all the rest of them, 0, 0. If you plot that one first, you can move it around, plot the other ones based on that. I guess it doesn't really, generic shape, I always call this an S curve, even though it doesn't really look like an S, it's more like a sideways Z, maybe, I don't know. But it's a curve is what we need to remember. And it curves back around, you know. Domain. If you notice we have negative values, we can put in any value into that function and get a real numbered answer. So the domain, the x values, all x values work. So that's negative infinity, positive infinity. And then the y value, same thing. This is going to continue going up and down forever. So we go negative infinity to infinity. All right, let's transform this stuff. So I'm gonna go ahead and do number 3 here. Number 3, it's the square root. So make sure you're paying attention to the function here. It's the square root function. So I'm gonna quickly just plot the 1, 2, 4. And for this one, I'm just gonna do 3 points because that's good enough. So there we go. That is our parent function. So let's do the transformation. And we've been doing this a lot. So the -2 in there, that is a horizontal shift. Remember, the horizontal shifts are opposite of what you'd think. So since it's -2, it goes right 2 and then up 3. So from each point goes right 1, 2, up 1, 2, 3. Right 1, 2, up 1, 2, 3. Right 1, 2, up 1, 2, 3. I did one of those weird mistakes. I wrote the wrong number there. All right, there we go. And there is our there's our graph on that one. Let's see. Yeah, let's do number 6. That's a good one. So plot the original. It's so nice that the original isn't 1, 2, 3, 4. So the original doesn't quite fit, and that's because we are flipping it. But it is helpful to still have to know where those original points are. All right, so that's up 1. So first thing I'm going to do, or let's just name all the. So first, the negative flips it. The 2 here, that's going to be a stretch by a factor of 2. And then +2 is left 2. -3 is down 3. So a lot going on with this one. So I'm going to do the flip first. The flip, the 0, 0 stays here. Since this is 1 above the x-axis, when I flip it, the new point is 1 below. 2 above, 2 below. All right. So each of those, now I'm going to do a stretch in green. The stretch, the 0, 0 stays. The distance from the x-axis here is 2. I need to stretch, or excuse me, this one is 1. I need to stretch that by a factor of 2. So the new distance is going to be 1 away from the x-axis. This one has a distance of 2 from the x-axis. When I stretch it by a factor of 2, the new distance is going to be 4. So it's going to be 1, 2, 3, 4. All right. And then from the green points, I'm going to do the stretches. Left 2, down 3. So 1, 2, down 1, 2, 3. Left 1, 2, down 1, 2, 3. Left 1, 2, down 1, 2, 3. And here is the final graph. I don't know, I feel like it'll look better if I put in little dotted lines here to show this is like the work in progress. So that was the flip. The green is the stretch. And then the blue is the final with everything done. Fun times. All right. So let's look at a, I think we're good. Yeah, let's look at, we'll do number 10 here. Number 10, this is a cubic function. Make sure you're paying attention with the right here. So let's plot the original function real quick. So the cubic function starts 0, 0. And the cubic function, because it's hard to get everything to fit with the stretches, just plotting those 3 points works. And we will just do, hold on, I want that to be a dotted line. Just plot the 3 points for the cubic function and just translate those 3 points. It'll start, it's not going to fit if we do the other points. So that's okay. Just those 3 are good enough. So there are 2 transformations. First, the 2 out front, that's going to stretch it. And I've forgotten our stretch. So stretch by a factor of 2. So this point here does not change, stays at 0, 0. Just multiply the distance from the x-axis now. So this is 1 above. When I stretch it by a factor of 2, it'll be 2 above. This is 1 below. When I stretch it by a factor of 2, it will be 2 below. All right. And then from each of those green points, I'm going to show the work in progress. So from each of the green points, all right, I'm going to move, do the shift. That's inside the parentheses again in the cube. So that's going to be a shift to left 1. Everything goes left 1. So left 1, left 1, left 1. And then the blue graph is the final product with everything done. And that looks messy, but as long as we get the points there we go. All right. Moving on. So this, we did a bunch of these. You should be pretty good at this by now. What I want you to do is make sure you pay attention. What is the parent function on these? So identify the parent function. So if you see the square root symbol, the parent function is the square root function. All right. And then you need to state what the transformation is. This x is outside of the square root. So that's a vertical shift. That's going to be down 6. All right. Let's do one with a bunch of them. So pay attention here. It has a cube there. So this means this is the cube function. All right. And there's a lot going on. The 2 is going to stretch it. The +5 is going to be left 5. The +7 is going to be up 7. And one more, show you number 10. Pay attention. It has the square root function there. So we are going to, again, that's the square root. So then the negative flips it. The 3 stretches it. The -4 shifts it to the right 4, and the -2 shifts it down 2. All right. Things you want to pay attention to. If it's the number in front, this is going to be a shrink. If it's less than 4, 7/4 is greater than 1. So that's going to be a stretch with that 7/4. But we've done a ton of these. You should be pretty good at them by now. So we're going to move on. You can skip this section, the section 2 exploration. We won't be doing that. This one we are writing. We've done a bunch of these as well. So just make sure you're putting things in the correct spot here. So we have a down 4 and a right 2. So when we write out this function is going to be y square root. The right 2 is going to be -2 underneath the square root with it. The down 4 is going to be -4 outside of the square root. All right. If it helps, put parentheses around this to just to show that that whole thing's getting square rooted and this 4 is not. Let's look at number 4. Bit going on with that one. There is a reflex, a stretch, a vertical stretch of 4, and then we go down 2 with the cube. So y is equal, the reflex makes it a negative. The vertical stretch of 4, we put a 4 out in front, down 2. Since there's not a horizontal shift, I don't need parentheses, just be x cubed. And then the down 2 is going to be -2 at the end. All right. I think you guys are probably good on the rest of those. Those should be pretty quick. All right. So these, what you want to do, we're going to write the function, the equation of the graph. What you're looking for is the base general form of the graph. What the parent function is. There's no vertical stretches or shrinks. So we don't need to worry about having a number out in front. There are reflections, but it's just going to be shifts. So we just need to identify how far it shifts based on where that important point is at. We don't need to worry about stretches or shrinks. First of all, this V shape, that's the absolute value function. That's the first thing you need to recognize, the absolute value. So it's going to be y is equal to, the important point is normally at 0, 0. This is shifted up 1, 2, 3. So it's going to be y is equal to absolute value of x plus 3. That's the shift up 3. All right. This is the quadratic function. It's that U shape. All right, and this is shifted to the left 1, 2, 3, 4, 5. So when we do this one, it's going to be x plus 5, and the quadratic has the square. This one, that's half. This is a square root function, and it's shifted down 1, 2, 3. So here, y is equal to is square root of x, nothing inside the square root with the x, and it's just -3. All right, this one here, upside down, this is a quadratic. Again, it is reflected. Normally it's up like that, so there's going to be a negative out in front. And then it's shifted to the left 1 or to the right 1, 2, 3, 4. So that's going to be x minus 4 squared, and then shifted up 1, 2, 3, 4, x, then plus 4. This is the cubic function. So this is just to the left 1, 2, 3, 4, 5, and then down 2. So that's going to be y is equal to x plus 5 cubed minus 2. And then the last one, this is another absolute value. This is left 1, 2, 2, and then down 1, 2, 3, 4, 5, 6. So it's going to be absolute value of x plus 2. That's going to be the shift left 2, and then minus 6. All right. We're going to skip this. We're not going to worry about domain and range on that. So you can skip the section 2A, etc. in that. We're going to skip these graphing ones. Yeah, we're going to skip those graphing ones. We've done enough graphing, but you could go ahead and do these. These should be pretty quick. These are just all the different functions that we've been working with. Identify the parent function. All right, so what you want to look for, let's see, we'll do one of each. So like this first one, this has the square root symbol in it. So this is the square root function. And so that gets shifted, that's left 4, down 5. This next one below it has a cube. So that is the cubic function. So the cube. The 3 out in front is going to be a stretch. And then the +2 is in parentheses. So that's going to be -2 to the left. And we'll keep just going down. That has a square, so that's what we're looking for there. So that's the quadratic function. 2/3 is going to be a shrink. +8 is going to shift it up 8. And then we'll do one more down here. Remember, this is absolute value with those absolute value brackets. So parent function's absolute value. The 1/4 is a stretch. Nope, it is not a stretch. That's less than 1. So that is a shrink. And then the -3 is, that's going to be a right 3. Last, I'm not going to do this one for you, but if you prefer, we can rewrite this as -3/4 times the square root of x minus 7 minus 2. All right, so you can take this -3 out in front and divide by 4 and just make it its own fraction, put it out front. And that should make it easier to figure out that whole one for you. So, and then last, you are writing, make sure you're paying attention to what the parent function is. The quadratic is the x squared function. So you need to make sure you are writing this out properly. Left 7 is going to be +7 inside parentheses, and you need to square it, and then up 3. So we've done a bunch of these. Attention to what the function is, like square root, shrink 1, so it's going to be y is equal to the reflex is minus the shrink by 1/6. It's a square root function, so you need to put a square root down to. All right, so pay attention to the function. And we've done this. We're not gonna, you don't need to worry about listing the coordinate for the new point. Just write the equation and give the parent function. And that does it for this unit. Yeah, next time we will be talking about inverse functions. Fun times. See you then.